Hello everyone, welcome to my programming club. Today we'll be solving another daily lead code challenge, and the challenge name is predict the winner. So the challenge statement is like this: you are given an integer array nums. Two players are playing the game with the array, and those players are player 1 and player 2. Player 1 and 2 take turns with player 1 starting first. So what do these players do? Both of these players start the game with a score 0. So initially their score is 0. At each turn, the player takes one of the numbers from either end of the array, which reduces the size of the array by 1. The player adds the chosen number to their score. So what are the players doing? Let's say this is the input array. When there is a turn for a player, let's say A, it's A's turn, then he can choose either from this end or this end, and whatever he chooses, and that value will be added to his score. Let's say this is a variable called a score. Then let's say he chooses the x value, so his current score will be updated to plus value of x. Similarly, these rules will be applied to B player or the second player. So till now I hope the program statement is clear to you. The game ends when there are no more elements in the array. So the game will end when there are no elements to be selected. For example, let's say this is the sample input. Let me quickly copy it. Yeah, this is the sample input given. Player 1 is starting first. Let's call him P1. Let's call this player as P2. Now player 1 is having choices either to select this end or this end, and both are playing to win. Both are playing to win. So both are playing optimally, such that they will get the maximum score. So what we have to do? We have to return true if player 1 can win the game, or even if the scores are equal, then also player 1 is considered a winner. If let's say at the end of game their scores are S1 and S2, now we have to return whether this condition holds true or not. Either S1 score is greater than S2 or it is equal to S2. In those cases we will return true, else we will return false. It's stated that both are playing optimally. By optimally it means both are playing to win, to maximize their score. So I hope till now the program statement is clear to you. Then the constraints part, in the constraints part, the length of the array is given of the order 20, and size of the elements in the array is given of the order 10 raised to power 7. So if we let's suppose a single player is making choices, there are no two players, there is a single player. Now for a single player there will be two choices. either to pick from the left side or pick from the right side. So let's say the input size of array is n, then in total there will be 2 raised to power n choices. Now here the input size is 20, so inputs n here is 20, 2 raised to power 20. So what is 2 raised to power 20? This is 2 raised to power 20. 2 raised to power 20 is this much, which is clearly lesser than 10 raised to power 8 operations allowed in 1 second. So for those of you who do not know how the time complexity of accepted solution varies according to input size, I will provide a link for an article explaining this. Then you will get a clearer understanding what I am talking about here. 10 raised to power 8 operations are allowed in 1 second, which is clearly lesser than 10 raised to power 8. It's of the order 10 raised to power 7. So we will get AC. But the question lies, can we do better? If you observe this problem is satisfying two criteria. What are those criteria? Overlapping subproblems and optimal substructure. What is overlapping subproblems? Let's say since there are two players making the choices, let's say initially one represents the elements which are picked and 0 represents elements which are not picked. Initially the state is like this. This is for after player 1 have made his choice, and then let's say initially the state is like this after player 2 have made his choice. Now if let's say in some another scenario player 1 decided to go with the right hand side choice, this one, then this state of the board after player 2 will make his choice here. Please ignore the extra zeros. This one is extra. Then this state will be repeated. As you can see, this is already calculated here. Already calculated. We are doing extra work. And these are overlapping subproblems. So this extra work, what it means is there is a part of a problem that is being calculated again and again. That is overlapping subproblems. What is optimal substructure? Means if we divide the let's say this is a bigger problem, it's divided into smaller parts. If we can combine the solution of these smaller parts and get the solution for the bigger part. Then it's called optimal substructure. I'll provide a link for these two. You can check it out in that article or say blog. So what we have to do in order to remove this extra work, I will be removing. Let me quickly change the color. How to avoid extra work and thus make our previous solution faster. We'll save the board state, save the it's the array, so array state. We will save array state. How will we be saving array state? By array state I mean which elements are selected and which are not. So the array size is given of the order 20, and for a integer type variable there are 32 bits which can easily accommodate 20 bits to represent array state. So let's say we calculated array state x somewhere, and now we are again at array state in some another choices set, in some another set of choices we encounter same array state again. What we'll do in this condition, we'll just return the pre-computed array state. Let's call this we'll return the pre-computed array state, and we'll not proceed for its calculation. So calculation part will not be done. We'll simply memorizing the result for a particular array state. So I hope till now it's clear. Now let's quickly move to the coding part. There the things will be more clearer to you. So now let's move to the coding part. So this is the coding part of the problem. Let me quickly zoom out. Yeah, what we have done is, this is the size of the given array, and this is the array state array that I was talking about. This is for storing the result for a array state resulting after a set of choices from the players. So what we'll be doing is, we are asked that whether the first player's score is greater than or equal to the second player. So we'll be checking their difference, checking the difference of the scores of player 1 and player 2. What we are basically checking, we are checking, let's say P1 is the score for player 1 and P2 is the score of player 2. We are checking for this condition. If this condition holds true, we will return true, otherwise we will return false. So here this is just a basic recursive function. So we at each state of array given, each player have two choices, either to take from the left side or to take from the right side. So these are two choices. This one is for taking from left side and this one is for taking from right side. What we are doing is we are using two pointers left and right, two pointers left and right to keep track of the ends of the given array. So as soon as left pointer exceeds the right pointer, initially left is pointing to 0 and right is pointing to size minus 1th index. So as soon as the left exceeds right, will return 0. It means there are no elements left. There are no elements left to be selected. So initially for every, how will be representing the state? Let's say current array state. Let's say initially the current array state will be initialized to 0. Current array state will be a 32-bit integer variable. So all the 32 bits are 0 initially. Let's say I selected the rightmost value and the rightmost value is of index, let's say 5. Then what I will do, I'll set the 5th bit. I'll shift 1 to the 5 bits and I will OR it with current array state. So what this will do, let's say this is the 0th bits, 1 2 3 4 and this is the 5th bit. The 5th bit will be set 1 and rest all the bits will be 0 as of now in the current array state. This is how we are storing the decisions we are making and representing the current array state with a 32-bit integer, or whichever language you are choosing, whichever the size the integer is of in that language. Generally it's of 32 bits only. So this current array state is representing the current state of array, and array state is the array to memorizes all the states that we encountered while making decisions. So this is how we are storing the current array our decisions in current array state. And this is if we decide to pick the right element, this is if we decide to pick the left element. And if we have encountered this array state before, we have encountered this array state before, then no need to recalculate it and save some computation. So pardon please if some spelling is incorrect. I hope you are able to understand. And yeah, at last we will be storing this current array state in the array state array. So this is pretty much it, and we will be taking maximum of these two options since every player is playing optimally. So this wraps up the solution for the problem. Thank you for watching. Thank you.